Okay. Right. Okay, just record it too. I try and set up the streaming thing to see if that will. I think it should be wicked. If not, I'll have a copy idea thing. Right. Yeah, I searched it too and you can't find it. Yeah, literally put at UV Robotics Society and then you'll find it. Yeah, at UV Robotics Society, no spaces in between. Yeah. But I'm not seeing like a live stream on it.
Oh yeah, because
Yeah, we email us. We email. We'll have the extra stuff. UV Robotics Society and all.
actually slow down that.
No, but I was reading up on some stuff and basically I was telling them it seemed like so Ross have a Windows Vision, right? So the two main things that we use to run the at least from my understanding, the two main things we need to run um to actually simulate the environment that we'll be using for the competition is Rust, which we'll basically be using to design the control system for the robot. So that's where we're doing all the code and stuff like that. And the actual simulation environment is something called Gazebo, which is an industry standard robotic simulation environment. So basically that will simulate the bot itself, and Rust is what we're using to kind of be the control system for the robot.
Right.
So both of them will just be feeding into each other to get data out of Gazebo into Rust, and you can use that information to do up your code, send controls back to Gazebo, right? And both of those things had a run in.
So when you actually put them together, your robot, that's in this.
So from my understanding, how the competition will work is that they'll give you like a predefined Gazebo file with the robot mostly built already, and you just have basically you'll just have like an interface on your robot. You'll be controlling your robot through, and you're using Rust to kind of control that interface basically, right? And both of those things don't want you to run it inside of Docker, just for the sake of because Docker is just like a virtual environment. So when you like add plugins and stuff like that, everything will be inside that. So when you're submitting it, they have like the whole container.
Also, you would not have to do it separately. Just do it right there.
Yeah, yeah. So Docker is basically a virtual environment, a virtual machine, right? Um, so right. So what I was looking at is that Rust does have a a Windows version that we should be able to run, right? However, Gazebo, while they do have a Windows version on their website, it's saying that it it have like known errors and it have known issues that there's pop up, so they don't really recommend it and support it. So, and the way that Docker does work, Docker does use Docker. You can treat it like a virtual machine, but do you know what a kernel is? A kernel. Wait, so, huh? The army? No, no. Okay.
That's not code.
Okay, so
Do you think of
yeah, kernels. Okay, KERN. Right,
sounds familiar, but
right. So when you have an operating system, right, the basic layer of the operating system is something called a kernel. So that is the actual code that is interface with the different physical hardware on your computer, right?
like people are studying.
No, that is like if you have a OS on a computer.
Yeah.
So like Windows have its own kernel,
Yeah.
and then Linux, even though you have like multiple distros, all of them is use the same kernel. So if you have a computer, the kernel is what does like allow the GPU to communicate with the CPU, the CPU to communicate with the RAM, stuff like that.
More like the BIOS.
The BIOS is specifically a software for the motherboard. So that is the kernel, right? So when you have uh, a Docker container, that is use the underlying kernel of the operating system you're running on. Basically, that means if you have a Windows machine and you install Docker onto it, you cannot run Linux stuff inside that Docker container. And if you install Docker onto Linux, you cannot run Windows stuff on that. So we basically,
It's not that's
yeah. So basically, we had to get a Linux machine to run Docker to then run the
so in
yeah. So we can run it on Mac because Gazebo has supported stuff for Mac.
so my eyes even cool.
So
I have a Mac but it's at desktop. I can't bring it here. You mean like it's one of them big Mac PC? Huh? I think yeah, but that's a
yeah, we have the HDMI cord right here.
think about it. If you have a home desktop, you could simply put the monitor there and have it right. It's true, but then add a carry on. It's for the cause. True.
Right. So basically, what I think is, if we're doing this, we can run it on Mac, um, or we could run it on a virtual machine and hope the performance is good enough.
Yeah, because then like sometimes even if you have like a Windows machine, I know a friend of mine is like character.
Yeah.
He's basically run Linux on his.
Right. So you could do that, which is basically dual booting your computer. So that is if you have two drives in your laptop or something, you just install Linux onto one and Windows onto one, so you have best of both worlds basically. So that was one option I was considering. Or if anybody had like a desktop, we could just straight up install Linux onto it and run it. So we could try and install stuff onto Windows, but from what I've seen, I don't think we should trust that fully because Gazebo have known issues. No, it just glitches when you run properly when you start the code.
The options.
So the options that we have is run it on a Mac device.
I'm not. It's fine.
Yeah, Mac just fine.
Wait, if I remember they said with the code and everything,
Mhm.
is there a way for you to just do the code? Like I remember they was talking about stuff with like GitHub, right?
Yeah,
Is there a way for us to do the code, but anything that we run would just be off of like one person?
we could do that. Yes.
Because that's what I was thinking. Like if we just basically have something where we could just do up the code, and then anything we actually have to run to do the solution, and just be off.
Yes, one person's device.
Yeah.
We could do
Yeah,
that.
but then
That
like test, you know.
yeah. You see,
Yeah, well, it would just be that we would have to rehire now.
um,
Option is on Mac.
right.
What was your option?
The next option is run it on a virtual machine on a Windows device.
Windows machine Docker.
No, so you basically gonna install VirtualBox onto your Windows machine, create a Linux virtual machine,
Okay.
install Docker onto that,
Oh,
and then install Gazebo and take it into that.
it's just kind of like where some people just get like, um, so you can do that with Mac too. Right? Like you could get like the Apple OS in a virtual machine on our
Yeah, yeah. So you can get Hackintosh on a virtual machine, Windows. Hackintosh is the like cracked
Oh,
um Mac thing. Right. The problem with that is that you basically had to commit resources to the virtual machine. So at best, you'll get like half the performance of your actual machine. And when running this environment, it seemed like it's a pretty intensive environment because they recommend like i5s and like a decent GPU at minimum. Yeah. So the third option for men who have Windows machine is to do a dual boot or just straight up install Linux onto the machine. So a dual boot is basically if you have two drives on your system, you can install Linux onto one, Windows onto one, and then when you boot in your laptop, you can choose which one you want to run.
Sure, that's something like that.
Yeah. So that's our next thing, right? So like it depends on your device too.
So you actually need to
Because
have to.
yeah, well you had to have two drives, or if you have one drive, you have a way to split the drive, partition the drive. Yeah. So you can still do it with one drive. The problem with that is some laptop manufacturers does lock down the system where you can't do a dual. So it depends on your laptop. We'll have to find out.
I would.
All of this is on a laptop.
If I want to buy that stuff, girl, that's why I need that stuff.
I say I'm man about Mac. Not saying. I say, honestly, I put option one.
Right, so the back end.
Yeah, I don't know that. Because the thing is like, because if it's like, okay, for instance, let's say we use the GitHub option, and he has a desktop.
Mm-hmm.
Like, is it that we really? So I understand for testing purposes, it would be good if everybody could be able to like test what they have.
So like the thing is like from how I see this competition structured, um, usually if you have a competition like this, you would want everybody to be able to do development at the same time. Because basically once you get like the structure of it out of the way, you had to fine tune everything and that's gonna take a lot of simulation time. So ideally it might be better to have at least two or three people running it so we could like if we have like different ideas we could chase down the different ideas at the same time. Because like was telling Daniel, the first task seemed like something called a control system. You're setting up a control system, right? And um that that is take time to tune. And you start manually tune it sometimes. So that's like basically that process could look like run a simulation, see how shit it looking, modify some parameters, run it again, hope it work slightly better, run it again, slightly better, until you actually get it to work how you want it to. Yeah,
Kind of like tree.
yeah, to that extent, but you manually train it here. So ideally, it would be nice if we could get it to run on like a few computers, and then the whole point of this too is like everybody wants to learn, so best way to learn is do things yourself. You have a desktop, eh?
Yeah.
You have multiple drives on your desktop?
Yeah, if I remember, you have two SSDs.
We could probably, we could, if you're willing, we could probably try to figure out how to do a deal with.
So if the laptop could have
Try and
made you or
let's,
cool.
let's,
See,
yeah, well, the thing is like we don't need everybody to do it, but the more the merrier, right?
wait.
So,
How powerful are we?
so from their site, they recommend like a recent Gen i5 at lowest, and they say you don't necessarily need a graphics card, but if you have one, it'll run faster. And it was recommended like a 9080. Sorry?
That's around that.
Yeah, 8 gigabytes of RAM as well. See if I find these. RAM, 8 gigs of RAM, and then the GPU. I can't remember the specs specifically.
It provides around telco and I5, but then multi-core.
Mm-hmm. the specifier graphics card.
NVIDIA GTX 6.
Okay, that's a old.
It specifies that it has to be a video, that's just an example.
Said NVIDIA graphics card.
Oh yeah, but AMD card.
Yeah.
That just system requirements.
Yeah, that is basic system requirements.
Yeah, because I've been AMD graphics cards, I'm not sure that.
But if I could install Linux onto this as like a dual boot, we could use mine because this is a Ryzen 5 and I have a 3050 in this.
Because I have a AMD Ryzen 9.
Beat up a graphics card. So we gotta figure out something.
I feel,
Yeah.
honestly, I feel like we could be kind of sponsored.
Aha! It's funny.
When mine comes, I have some nice computers in the lab.
Yeah, yes, and them will be just very fast. And good ask. Because the thing is, like, if we use computers, then yeah, it would just be to come here to. Matter of fact, there's a whole course on robotics. There's shit. I mean, that course is not robotics here.
That is robotics theory. It don't have no practical shit to that. Well, I mean, it does have a few practical shit, but it's mostly like maths. It's not simulation.
How about the computers? Like,
That means shit.
another?
We have one lab with decent computers, but I don't think it will be fast enough for what we want. Yeah, the microbee lab. And see, what's that man not scratching head? That's we good computers that I'm not scratching head.
Like, I'll ask DCIT and see what they say. Tell DCIT. Hey.
Yeah.
I'm sure CIT will probably tell us that they installed it.
What is the computer competition? To be honest, I think like robotics in general is just not serious.
No. This run most of the shit on Linux. It's just that Linux and Mac have very similar kernels, so I'll say cross compatible. Windows was the one that was kind of like, huh?
I used to have a Mac.
Shit, dog, you can't survive in engineering without Mac. Huh?
That is very true. Like literally, with what was it? Multi-sit, all that kind of thing. I was like, yeah, it's my God. Like that. So
Like Mac.
like this
This,
software.
yeah, all the software we use, a lot of them exclusive to Windows.
The thing is, I find like Windows more use like general.
Yeah.
I kind of grew up in that much, and it's like, yeah, this is my first Windows app.
Like I grew up with since Windows XP,
Yeah.
same like Windows XP with 7.
I just like the UI especially. Like I'm not really one to like dig up like my computer. Just it works for what I had to. And then there was like
So there's the options for actually running it. Do we have access to the actual gazebo file? Where did it find all that information?
it's competition first and two on that page. So but there and then speak also.
Task description, technical guide, the kickoff. Okay, so I'm just check one thing. Okay. VRX. Suppose in gazebo sim runs to by default. Gazebo partner has to run started instructions here. So off reference country. Very actual bus topics. Because the next thing I'm wondering is like, again, I could be wrong about this, right? But basically, gazebo is just a simulation environment, right? So it's kind of like whoever familiar with like Unity. It's basically like yeah. So it's basically just an engine, and then you just have a project inside that engine. So from what I understand, the competition will have to give you a specific project to run in Gazebo. And I'm wondering if we have access to that right now. 'Cause I don't think if I think if you install Gazebo, you will actually get what they want you to run.
I said that was if I like you would kind of build.
Yeah.
When are they planning to announce it? For this year?
You can check the technical guide.
Okay. Okay. Did you get a reply from them by chance? Introduction, goal, submission, competence, scoring, competition. Phase 1, simply check it. Start early and then get into the just right. So, next is it is on
Hey, you're looking for seeing it's not live.
sorry?
The YouTube. Seeing
Okay, I don't know why it's not live, but I am recording it in OBS, so I could always just upload it after.
try stop streaming and then start. So, so
But there was a
Anyway, I recorded it, so I could always upload it after. I could record it on my machine itself. Okay, right. Technical guides, right. All teams must use the simulated version of the Wave Adaptive Module Virtual Service Graph distributed by the VRX software. Okay, so it seemed like to give it to us from this repo. Somewhere in this repo, probably here. So assuming somewhere inside this repo, it actually is. It's alright. I think I'm a ball shooter. I think I'm a ball shooter on it. The craft. Shoot balls.
wait, yeah, because did they mention that in one of the tasks they show in the video, when you just go by this dot thing, you have to basically
Shoot down.
shoot a target with us
You? Okay. Interesting. Gazebo. So submission and I think I might have a sorry. Might.
least soon I'll be here next week. There'll be 2 meetings and she already coach our team.
Yeah.
So she should have some good everything. I hope so.
You sure? It was like Mana Rana the last competition. It was some elect fellas that was competing in VRX before.
So, or you mean like what happened here?
Yeah, because
Okay. I will let you wait till after some probably like if you following me after we catch some hearing of actually doing
yeah,
maybe. But wouldn't it be easier online? Yes.
it's, you see that online meeting sounds like two-sided because people don't like to talk and interact, but it's more convenient.
Like eating us out.
Yeah.
I thought really influencing you said
Yeah, but you see, you talking with your mouth full of, you wouldn't do that on an online meeting.
that's well the thing. I didn't even know I
So, like on an online meeting, it's like one or two man talking the whole time, and everybody just sit down vibing. I'm watching Twitch, and next man watching YouTube. And next,
like man had the mental find when he there.
yeah, see.
Somebody sleeping with me.
Yeah. Well, the meeting and close back yeah.
So,
And I remember in Form 6,
mm.
when we had online class, a man
Hey,
hey,
you good?
Yeah.
Okay, but
Think about
read. Yeah. So we had the online class, right? And a man get on the bell. He thought that he turned off his camera. Okay, you know when you join a Zoom meeting, you
yeah.
start to take off the camera sometimes. So the man thought that he took off the camera and he turned it so he had his back to the camera and you can see his TV in the background and he's playing game while the meeting's going on. I was like, not quite red hand. Oh, that's so funny though.
I remember those like in between you like we were trading for the like his online data. It was like right after COVID. Like me and one of my co-workers was also training now, like we just they casually playing game while like just saying what's up. No, it's like I could hear the man like pressing the buttons on his controller. I'm like, bro, I can hear the bro.
Yeah,
He's switch.
it, when I was in year two, I had like a big group meeting that night, right? I was group leader, right? So I was supposed to be on time and thing, right? Meeting's supposed to start 8 o'clock. I in South Park. Check my phone, 8 o'clock. I was like, shit, I have a meeting now. So like, I messaged the group chat, I was like, hey, y'all, we could push back the meeting by half an hour. Then nobody responded to her. So I fly up there. I reach from South Park to my apartment in St. Augustine in 24 minutes.
That's crazy. What? That's crazy.
I didn't even talk about like highway to highway. Like from the time I sit on my car to the time I jump on my car, 24
What?
minutes.
It was fine.
I knew you were just people. Well, that's how we was. We started meeting.
Oh, Teams controller. The Teams Docker container.
Just technical, right? It's like
Shit. When the time.
I feel like I would kind of expect us to like something.
I, okay, well, let's start from the top. Yeah, there is.
So you got no start. You don't have a huh? From that no start.
I mean, it's a fun that no start.
That's what I'm saying.
People doing that step.
No, but no, it's not that. It's not that. Tells you about it's like
A while ago.
it's like Late semester one.
What?
Late one?
Dog. Oh
Late
my
semester one.
goodness. Last year?
Let me see if we can run through some stuff and like see if we can figure out things, clarify some ideas and concepts and things like that, right?
I hope you understand.
So where oh, you just want to start at the top of the technical document.
Yeah.
Right, so the purpose of this document is to provide So the purpose of this document is to provide the VRX team with information necessary to successfully prepare for and participate in your VRX competition. It covers the following topics: the competition goals, approaches, robotic platform, the propulsion, sensor configuration, generic information about how task works, runs, and the environmental envelopes, the application programming interface, and instructions for submitting your code for the competition. For details of the individual tasks in the competition, see the task descriptions. Or you want to look at the task, at least like the first one, the second one. I don't know if I'll do that already.
But it should be first one. Because we can do them.
Yeah.
Oh, I think
Yes. Oh, okay, well, and this is wrong too. So 1.2 was the latest one. Okay. Right, so task description. Right, so the first task is station keeping, right? So the system should be capable of performing localizations by fusing sensor data, GPS, IMU, etc., and maintaining the USV position and heading in the presence of an environmental forcing, so winds, waves, and stuff like that. The performance in this task is measured using a combined the pose error distance given as to give us the formula. We don't really care about it. But it's basically just you're taking the distance and then you're adding it to the angle. So like if just how my pencil keys. So if literally if you have this is the point that you want to be at and this is your UAV, the distance what is it? Euclidean distance in meters. So I believe Euclidean distance is literally just a straight line in three-dimensional space. Right? So it's literally just from here to here, the distance, and then the h, which is the position difference, is basically like the angular difference. So like when we say here is north, it will literally check the angle of the UAV from north. So in this drawing here, the angle is 0. So if we have like this would be our angle h in radians. Yeah, and then multiplying that by some factor, so that is your error pose, right? Um, they have like a weighting term for KD and stuff like that, right? So D is just your distance, KD is some kind of weight, and H is your angle, right? Um, and so they're just saying that the poses the error is calculated at each instance in time, simulation time, and the total score, the mean score would basically be the average over all time, right? So basically, the faster you can get your bot to go to the point and stay at the point, the lower the average error,
I
right?
was watching the scoring. I realized the score like it's get a score based on the error that you get. So the it's at the top of the board with people.
Yeah.
Also like the codes and stuff.
Yeah. So basically, to minimize the error, you want to design a system so that your bot will go fast to the point and stay at that point, right? Um, and then they just have like different stages of the sequence. They have like an initial stage, a ready stage, running, and stuff like that. When you're doing development, you can actually, when you're actually building out your system, you should be able to see the pose errors, but you won't be able to see that during the actual running of the computer. Yeah. Right? And then they have the scoring and stuff like that. So I was telling Daniel, most likely, from at least reading this task is basically a controls task, right? So what that means is basically you want to design an algorithm such that the bot would be able to like autonomously move to the point and stay at the point as best as it could, right? So that is basically what this diagram was. This is like a diagram of a control system. So literally, I'll have your your set points, so set points outputs. So right. So basically, I have like the values that I want to measure. So like that'll be a sensor data. And you have your system, which would be your UAV, right? And then you have a controller. So basically, your controller would output. So basically, you have your set points. This is where you want to achieve, right? You have your system, which is the stuff that just get manipulated. So it's a simulation environment, right? And you have your controller, which is take the outputs from your system, manipulate it, and then output it to like your motor control or something like that. Right? And then you have like a feedback going back to your thing to check with like the error between it. And then you have like your disturbances. So your disturbances would affect your system, right? But you have no way of measuring that. So your controller, you're designing your controller so that it would be able to meet your objectives, but be robust enough to basically mitigate against disturbances, right? Because in the simulation environment, you'll have wind affecting it, so you think it drift, and you also have like waves, so you'll have resistance, and again, your currents in the water could make it drift and stuff like that, right? And you may even have like issues like sensor error and sensor noise, because a sensor will never output exactly what the real value is. You might see like so like let's say you have like a specific like temperature in the environment and it's a constant to the heat, your sensor might output like that like this is your reading you'll get out of your sensor. But this is your real reading. So the controller had to be able to like deal with all of that shit. Right?
Um, could we like uh,
Yes. So that's literally one method you could do. Yeah. Right? So it has like controls theories, like a whole thing in engineering. One of the most popular control types is something called a PID controller, right? Proportional integral derivative controller, right? And all that is literally this. Is literally you have a variable that you're measuring, which is x, and then you want to manipulate that variable using a proportional amount of it, integral, and then a derivative, right? So you're measuring something, and we want to manipulate it in such a way that we'll get a specific output that we want. And the way that we manipulate it is taking a variable, finding a proportion of it, then adding that to integral, a proportion of an integral of it, and adding that to a proportion of a differential of it, basically. And we, when you'll hear people talk about like tuning controllers just means you're adjusting this weighting values, right? So that is what I think the first task is. I could be wrong, so if anybody have any ideas and want to voice it, you can.
Yeah, next Tuesday.
Next Tuesday, I'm hoping.
Wait, what was the question?
If you have any other ideas on what it could be. Now, this isn't like the be all end all. This might be like the most robust part of our solution, but then we might have like little nuances that we had to implement, like logic, or we could do stuff like what he was recommending, where you find like the average like sensor value or something like that to help stabilize your sensor noise. So there's a bunch of different things we could look at, and then we had to figure out how to implement all of these things into code. And then simulate it and hope it works. And so that is literally first task. So this is like what we'll actually be doing in theory. Right? So now that we have like an actual idea what we want to do, we gotta see how they actually set up the environment to do everything. Scoring. Sorry? Okay, sorry. Right, so the competition is means of supporting engineering development for marine robotics challenges and marine autonomy in general. The task and scoring reflects this intent by emphasizing the foundational capabilities that lead to better autonomous performance, testing autonomy algorithms in a relative simulation environment is an effective and efficient and cost-effective approach when compared to challenges of testing system parameters in a physical environment. Right, system-based one. And so that's just saying why to do the whole system, right? The whole competition, right? Um, right. Evaluation of the VRX tasks will be performed in a specified evaluation environment composed of computational resources consistent with the system requirements for the VRX competition. Team submissions consistent of configuration and software will be executed by the VRX technical team to generate the task scoring. The details of the evaluation environment will be provided to the teams along with working examples and tutorials to allow teams to test their submission thoroughly within an equivalent evaluation environment. This should ensure that the performance of each team's submitted solutions will be equivalent to the performance during the development, right? So that basically means they just have their own environment that they'll run our stuff in and then score we are coding, right? The actual environment from what I was reading and like understanding is that basically we have gazebo. Right. So the same we using gazebo and we using Rust2, right? So and we had to run both of them Docker containers, right? So a Docker container is literally just like a box, a virtual environment, right? So you're gonna run gazebo in one and then Rust2 in the next one, I believe. It seemed like Gazebo will have some kind of API, and then from Rust2 we'll actually interface with this API. Here is where we'll do all like our development. This is what they gave us. Right, so they will give us the environment. We don't really have to mess around with anything. Or the only thing we get from this is the sensor information, which is the cameras, the LiDAR, the GPS, and two other sensors. I can't remember what it is. And then our job is basically to develop code in whatever way we see fit and basically pull our information from the API, do whatever computation we want with it, and then output some kind of result to control the robot, right? And
Don't you also need to build the robot itself, like materials and so on?
no, not for this competition.
Yeah, like simulation. So
Well,
you
you
have
have
to
to.
design a robot.
He's asking the same question I asked before, like if what he's actually using to put together the robot. So,
Yeah, because I need, if I remember correctly, you said you had to design like the robots.
is it saying like basically, like although so let's say they do give you like gazebo,
Yeah.
but it's where like you still have to because like they're saying each team would still have a different robot basically, and and it depends on what you put together for the task. I remember I think they mentioned that in the video.
Yeah.
Video.
Yeah, I believe so. What you say?
I watched
You do your work.
I pretty much just doing everything. Yeah, I watched it 10 hours.
Which
I
part of
remember
it?
they were saying that like the design that they had, it was like that was somebody's design crazy. I don't think that was the standard thing that everybody.
Where do you video?
Um,
Just Google VRX 2022.
yeah.
I don't know if
Yeah,
it's
that
so
was-
difficult.
Polygram by the timestamp.
We're welcoming the newcomers in too and not assuming any prior experience. We want everybody to be on the same page. After this kind of general, into two main parts. The first part is like our good old fashioned introduction to VRX. If you're new to VRX,
Yeah, let's start with the first part, and we'd like to start with some questions before entering into the meat of what is VRX, and just to motivate why we are doing this. And the first one is, why are we actually creating a competition based on a simulation? So we're going to show you just a few examples of what happens in the real world with real robots, and you can see here examples of a
Yeah, it's
competition
only
in
on Boston Dynamics
2015 called
retired a robot
DARPA
at last.
Robotics Challenge. And
Yeah, at last dead.
most of these robots are around like $1 million.
They say
You
too
can see
old.
what happens every time.
Old.
Very often, every time
Wait,
that they
wait,
try
I
to
work on
do
something.
something a little bit complicated, like they like to roll over the floor a lot. So robots are very expensive, are fragile, and this is unfortunately a very common situation.
You're working on.
Could you
Spot
go to
is
the next
the
one, Michael?
dog.
Thank you. Another example of a real world competition where real world robots are involved. You can see here, this is a team participating in a competition called RoboCup, where these robots, these little humanoid robots need to play soccer. So you can see here the size of a team. It's probably like, I don't know, 20 people around there. So some people need to do calibration, some other people need to be in charge of the robots, of the batteries, some other people need to be tweaking the code, other people are controlling different aspects of the game. So it's a very, very expensive game in terms of not the number of people. Go to the next one, Michael. Here are also a few questions, a few comments that maybe you have heard before every time that you are doing some kind of experiment with your robot in your lab or in the field. Maybe you have heard something like, it seems to be working. So we're not 100% sure, but it seems to be looking correct. It's not working right now, but I saw it working one time. Like I thought it happened one time, or it's stuck. So you don't know what's going on, but it's kind of frozen. This big question mark around everybody, like, I don't know what's going on, or what is it doing? Like these questions are very common, right? When you have real robots, and they are hard to answer because you need a lot of tools to introspect what's going on, and typically robots are complex. They have many, many pieces, many different components, and many things can go wrong, unfortunately. Could you go to the next one, Michael? So why do we use simulations then? Well, first of all, because computers are cheaper compared with typically like a robot, and they don't break as often. So they are like solid pieces of hardware typically. Also, like in comparison with all these examples that we talked before, right? Computers can be operated by a single person. You can have multiple computers in a team, and typically you can't afford so many robots in a single team. Also, the simulation in general, it's the tool that lets you control the environment. So you can, for example, isolate individual blocks of software. You can say, okay, for now, I don't want to tackle the perception at all. So I'm going to introspect the simulation to give me like the exact position of all the objects. And then you can continue with your testing your code, isolating that part, right, with perfect perception as an example. And then when all the pieces are typically working, maybe then you enable your perception. It's a tool also that lets you reproduce experiments. So imagine that, I don't know, you observed something fishy when you were testing. So you can go to your computer and try to prepare an experiment. You can try to load a world with the right setup, with the right configuration to reproduce the situation that was not behaving properly. And then you can debug what's going on until you find the solution. It can also let you modulate the complexity, which is the real problem, right? In general, in software. So you can start simple, like in the same spirit as VRX. We can propose different worlds, and each world has different levels of complexity. When you can tackle the easier worlds, you can move on to the more complex ones. And always, as always, we say simulation is we think it's a great tool, but it's a great tool probably where that you use it always in combination with real world testing. So this shouldn't be a tool that replaces real world testing. It's a complement. Just to illustrate this, and not giving you the impression that I'm making this up, like big companies like Waymo, for example, published some data in 2019. So with their autonomous car, they use simulation, and they have driven 10 billion autonomous miles in simulation, just to give you a sense of how, I guess, useful they think it is. Go to the next one, Michael. Okay, so hopefully I convince you that why we are creating a competition. You can see here, and fun competition.
And now this sort of brings us to virtual robotics, right? So the VRX is this effort that we have to bring the advantages of simulations and competitions to the maritime surface vehicle world, right? The VRX simulation environment, like in general, is this gazebo-based simulation for USVs, and we created it in the hopes they would help. Seeing teams had some part. We trust, right? And so the way the car you hope either new or involve like some kind of major example for an acoustic life is. This is sensor data, and it can maintain. And the point of this task is just to demonstrate that your system can localize itself by fusing sensor data, and it can maintain a position and a heading despite potential waves and wind. Right? And so to practice this, your WAM-V is spawned somewhere slightly random, and we publish a topic that gives you a goalpost that's relatively close by, and you just drive to the goal and you stay there. Right? In the video here, you can see my effort to do this teleoperating with a gamepad. It's not going super great, but the team with the lowest mean error distance at the end of the task is the winner. So if you get to the goal and you hold it, you're going to have the lowest mean score. So that's the best you can do. Right? This is, as I said, a task we do every year, and I think it's a good demonstration of the advantages of virtual competition because it allows us to isolate this core capability that you can build on to create a solid solution to other more complicated tasks. For the whole presentation, I'm going to turn it over to Carlos, and we'll get started on our intro to VRX.
Thank you, Michael. Yeah, let's start with the first part, and we'd like to start
with the points given. Right. In this case, the way we score you is just a slightly different. We record the minimum error distance you achieve for each waypoint, and then we average these together over all the waypoints. So it's like an average of your best results. Used a forum for communicating with teams and like competition related questions. This year that's getting updated to a Discord, which RoboNation has kindly set up for us. So that's the link there to join the Discord. Everybody is welcome to do that, encouraged to do that. And then finally, our 2023 website for VRX 2023 is now live, and that's also
with the simulator used in the previous editions. So before we were using what is called right now Gazebo Classic, and now we are going to be using Gazebo Sim, which is the newer generation of the Gazebo simulator. The reason for doing that, it's multiple. One is because it's currently the simulator that we actively maintain and that we actively develop. So we thought it was worth it to make this migration for the long run. And we know Gazebo Classic is going to be deprecated in just a few years, so it's worth to do that migration as soon as possible. But it also comes with some advantages. There's one visual advantage that's very good. So it's using Augur 2 instead of Augur 1, and that brings us something called physically based rendering, which you can see here on the screen how the dock looks without PBR and with PBR. So you can see that with PBR it gives you more texture and maybe like a feeling of a better feeling of how the material it is of the dock. In this case, it's more like a plastic or rubbery material. So I think it's a little bit more realistic in that way. The new Gazebo simulator has a lot of changes internally. So that's not something that should affect the end users or the participants here, but just out of curiosity, we are using something called the entity component system brought from the game community, which we think is going to benefit how in general Gazebo works. It has a way more modular design. So right now, for those who are familiar, Gazebo used to be like a monolithic project with very big code base with all the pieces in a single repository. Right now, it's a different approach. Right now, it's a collection of many different components that are living in different repositories. So we think it's a better design. And then typically what we expose as the API to access the actuators and the thruster and the sensors is the well-known ROS API. In the past, we were using ROS 1, and we took also this opportunity to migrate from ROS 1 to ROS 2 for the same reasons. And this is something that it's going to affect you if you were using ROS 1 before. So now you have two options, two possibilities. You could migrate your code to use ROS 2, or you could use a bridge. So you would have to bridge ROS 1, ROS 2, which is already there's already an existing bridge. You don't have to do it, but just so you know. I'd like to clarify also this aspect. What we are exposing is a very, very, very thin API, just to access a few topics for consuming all this information, the relevant information that you need. That doesn't mean that the way you program your code and your robots needs to be ROS. No, not at all. The ROS is strictly needed for accessing that API, but then once you consume that, you're free to do whatever you like. You can use ROS in Python, you can use ROS in C++, or you can use any other approach that you want or any other middleware that you want. As the only, I guess, thing that we're forcing you is to consume that via ROS tool. That's the only thing. Having said that, can we move on to the next one, which is related with the submission process? So
If I find it, I'll
I guess when you reach a bridge, you
Yeah, but from what I was reading, we don't have to physically build anything. At most, we might have like adjust a design in the thing.
in the program itself. Yeah,
Yeah.
that's what it's referring to. The actual.
Yeah. Yeah,
But
but I didn't say anything to indicate that, but again, I could be wrong. So if we find it, up, we could. But because it seemed like the what they're grading you on is the actual task and how well you complete it.
yeah, but I think it'd also be like the robot design in general and how you get to complete tasks because that would also they're not giving us a model to really master people.
Like,
It doesn't have to look good, but it just has to be practical, I guess.
because the reason I want to believe the not like make we do that is because then you gotta do like considerations like placement of sensors and stuff like that. Because that can make a big difference where you place your sensors. And if you know, I don't know. I mean, it very well could be that they expect you to design. So you can figure that out eventually. Yeah. Right. So submission. Hey, so it seemed like when we submit them, we'll have the container which run in Gazebo. Based on what he was saying, it have a chance that Ross might actually run inside here too. And then inside here, basically he's saying like the only purpose of Ross is to interface with the API because this so like basically you could do the actual simulation. Ross could basically be like the operating system for the robot where it will run like all the sensors and stuff like that. And then you had to interface with Ross to actually get sensor data out of it. And then basically when you do in your development, you can use anything you want to actually develop like the controller for your robot once it can interface with the API. So you could actually use Rust to do your controller, where you could go and write it from scratch in like Python or C or Java or Perl or whatever else you want to write it in. Okay. Um, so and then when you're submitting the whole Docker file. Because if you're developing this from scratch, remember, you gotta like import libraries and all that shit. So you will point out the Docker file is that all of those things will be installed inside Docker. So you're just basically giving them the whole container so they have everything just to run. They don't stress about like different configurations.
Wait, if you're saying that we could basically, like you were saying, right, well, we could like Python, would we need like a certain ID that would be compatible with that?
I mean, yeah, we probably have to get like a compatible ID, but most of the times you could just use Visual Studio or something. Visual Code. Well, we actually, the thing is like, a lot of these things would be like up in the air because one, the competition didn't actually start. Two, we don't have access to any of these things. Like we didn't actually set up anything. So as we go along and we actually like install something and see how it runs, then we could like debate on things and figure out what we want to work with.
like every time, like from like VRX 2019, VRX 2022, VRX 2023, there's always like update something,
Yeah,
add on something. So, and this one was like you add on something.
yeah.
So,
To be honest, we don't even know if the competition we're gonna run. We don't even know if the competition we're gonna run
serious.
because I haven't posted anything about it. Last year around this time is when they did post. So
The Java X, so, and that's our VRX labs are check the data
Robot, this is September, I think.
September.
But doesn't it be like every other
Yeah. So
November.
So it might be like, say, so that's how
Who's the other competition we supposed to do? The big one?
Huh?
Who's the big one?
master.
Robo Master.
But the thing with that one, like, you know, you need half of it.
Yeah, we gotta get real money. Gotta sell drugs though.
What are the some
Use the treasure.
I mean,
I have a man I will link you.
because now see an Anita source supplier.
No, no.
in terms of like transport, materials,
It's internet. That's international. But they move some to that.
I think it was China.
No, why does picking competition? Some American competition, some local. China's.
We'll go to Central. Yes, where can we find that?
Yeah, let me watch that one.
Need a little experience before we do that.
Campus in China.
And not to mention we also need
What,
money.
you
For what?
No, there's an exchange program for software engineering.
Yes.
So software engineering in St. Augustine is 2 years here and then 2 years in China. But it's like I think you have to pay for your own tuition or some shit.
I think it's
Wait, so wait, just on
Yeah.
what they offer that?
Yeah.
But it's like I think it's bio programming. Like that's some kind of
It's not real software engineering.
No man.
It's not real software engineering.
expensive.
so we would like to have something.
Yeah. Because it happened to people who want to do software engineering and just end up in comp sci or like yeah, wait. VRX is this. Oh, okay. Okay, so basically, like, okay, so basically, for the like ranking, for each task, they'll rank you first, second, third, going down based on your error, and then if you place first, second, or third, you'll get task points, and for each task, and then they'll add up all your task points over all your tasks to get a total. So I assume the lowest means you basically win. So basically you're aiming for like a low overall team number of points. Like golf? I don't know how golf is like.
And by golf, like depending on how good your shot is.
So if it's
Yeah, so
you try to
it's
get
basically
the
how
most
much
points
shots it takes to
out of 19.
Okay, well, I guess that's what it is. I don't know anything like sports related. That's just a book.
Oh, then I'll take my own case.
Okay, that,
really go golf is sport.
Trying to say,
Anything that does not involve dunking is not a sport.
Tiger, what's cool?
right. So it's just the phases.
You just think about it, isn't
You just eliminate so much more just.
But you just insult your ex president profession, you know.
Real, don't trap no top wall out. Unless you run in with a basketball in your hand.
Like, does he finish line have it?
You got energy for that?
That's our team.
Hey. Right, so
It's not
Really,
basketball.
Honestly, you see, man, 3 pointers.
That would be real funny.
Uh,
They run an extra.
This is no.
And the worst thing is they tell you, you can't travel it.
If you're swimming inside a beauty basketball.
No. What do you mean if I want to pull it in?
You miss, yes. You only finish there and you miss your dog.
At least you know what to play.
yeah. Right, so the competition will be executed using the gazebo simulation environment. All teams must use the simulated version of the Wave Adaptive Modular Vessel surface craft distributed with the VRX software. The
So that means that we'll have to design it.
It-
Giving us the vehicle.
it seems so based on at least a starting point or something you would get design. Right? So the vehicle as supplied by the VRX software is standard for all teams. No modification of the standard platform model is allowed during the competition. So from that, I assuming we're not allowed to modify it. So we'll actually have to see. The simulated vehicle includes models of rigid body dynamics, hydrodynamics, external forces, waves, and wind, and propulsion. The rigid body dynamics are captured by the gazebo physics engine. The hydrodynamics, external forces, and propulsion forces are generated by VRX plugins with fixed parameters. No modification of the standard VRX module parameters is allowed during the competition. Right, so the propulsion configuration as part of the competition, teams may customize the propulsion system with which their vehicle is equipped. Vehicle propulsion is provided by a set of identical thrusters. The details of the thruster modules are explained on the theory of operation page. Subsidy description. The section relates the theory given by the vehicle. Wind module, wave module. Module parameter sets of PMS that I can specify as C state plus and inside values. Huh? Anybody understand anything on this page? I want to just skip over this part. It's something with propulsion. We'll figure it out eventually. So the maximum number of allowed thrusters is 4. All thrusters have the ability to dynamically route and change. So this probably is what they're talking about with specifying like the design. It seems like it might be that you have like a fixed thing, but then you have to like choose your thruster positions. You might have to choose sensor position stuff like that on the actual thing stand and figure out how you want to control it. So that might be what they were talking about. Where you have like this is a specific solution from a specific group. Alright, in order to preserve realism, not all possible thruster positions will be accepted. The valid set of allowed positions are represented in figure 2 as 5 red bounding boxes in order for a thruster configuration to be considered valid. The origin of each thruster must be contained within one of these bounding boxes, and each bounding box must contain no more than one thruster. Teams can visit the VRX figure 2. Let's say 5 boxes. Oh, okay. 1, 2, 3, 4, and 1 in the center here. Teams can visit the VRX wiki for tutorial on customizing the vehicle. The same tutorial describes the format for the YAML file used for propulsion configuration. Provides weekend examples of YAML configurations. What is a YAML file? Yeah. All I know is like supposed to be a file that is like list dependencies or something like that.
Something like some serialization that is often used for writing.
During computation events, teams will need to provide a valid YAML file name trusted.config.yaml with their propulsion configuration. The dimension of the bounding boxes, we don't really care about that right now. But that is basically the size of the boxes and XYZ There are RPY. Right. Right. Component configuration. So, as with the propulsion system, teams should customize the other components with which their vehicles are equipped by choosing the type and placement of these components. Standard components include navigation sensors, GPS and IMU, perception sensors, camera sliders and acoustic receiver, and bolt shooters. In addition to configuring component types, the teams can also customize their placement. Many component types. Right, yeah, so the same thing I was saying, so we also choose sensor placements. Reflect the right, so available component types and their performance characteristics have been chosen to reflect commonly used components from the RoboTech's physical computation. These characteristics does not represent any specific sensor choice, but are meant to be representative of typical hardware options. Note while the sensor performance, specification, update rates, noise rates, etc. detailed below, the exact values of these specifications may change before the final release of this document. Nice. Navigation sensor. So a single standard navigation sensor representing a GPS aided IMU will be used for. Oh, okay. So it just specs for the sensors. So they actually want to go through this, or they want to just skip it over? I think we can just skip it over because this could just be important when we actually start the code. Right? Component placement. It's configurable via YAML file in order to create resolve this. Right, so again, it has specific areas you could customize the sensors in those two boxes, and you had to list the configuration in your YAML file.
So the weight
Now, we wouldn't have to consider weight. I assume they will have that in the simulation environment if they even consider it. We just have specified placement in 3 dimensions.
Well, that's I think about it. The fact that we states like the competition about it. I mean that we have like a good amount of time. Say like it happens like mid next year.
Yeah.
Like and say that they release it to be next year. Get like higher up, you know.
Yeah. Yeah, we could just genuinely get a real higher rank.
So you say it's cool,
Yeah, like I'll be in school, I would like like weekends or well, I don't.
You see what I say? Nobody wants to spare the operation.
Well, why you tell it? Use the engineer among us.
You too?
You here longer than me. You have more time in this club than me. So if you started now, you will carry it to the end.
You're more qualified than
Yeah,
me.
but like it don't make sense. We transition like spearheaders now, right? The man who started should be the man who finish it, and you have more time to finish it now, right? I only have a year again, no. You have two.
So you move carrots like
Yeah.
matter of fact, I'll go X so
Yeah.
And what you two are doing?
We could be working.
Supported from the sidelines.
Yeah.
Supported.
Moral support, dog.
Moral support, you some code for this.
Yeah, check it.
Real. They take the credit, yeah, I told you.
All I say is if I support you from the sidelines, we get a cheerleading costumes for you.
Yeah.
Real. Put on the proper on the side.
See them tape in the back.
Alright, so the task states initial, ready, run, and finished. A task can be in one of the four different states. The task state is set by Gazebo according to the task configuration. The current state is included in a task message periodically published on the task information ROS2 topic. Right? So the initial after Gazebo starts, the task is in the initial state, the robot's motion is fixed at a x, y, and your degrees of freedom, so x, y, and z degrees of freedom, but followed to move in z. Oh, so it's set in a fixed x and y position, but allowed to move in a z direction, so pitch. So it will be basically fixed in this direction and this direction, x, y, and y, but it allowed to move up and down according to the waves, right? Thus the pitch and roll degrees of freedom. Accepting. Yeah, there's like actual terms. Your pitch and roll. Your I think is like left to right movement. Pitch is up and down. Roll is left and. It's like if you have like a drone or something. Is the front of the drone? Yo is this way. Pitch is up and down, and roll is left to right. Um, so that basically means that the robot fixed in an X and Y position, it can move up and down in Z. It will be fixed in a yaw, so it means it can move left and right. It will be fixed straight up, but it will be able to move pitch this way, and be able to move this way. So basically, it fixed pointing in a certain direction, but the waves get affected. Right, so the purpose of this initial state is to allow for simulation startup transients to decay and for all the users' software to have sufficient time to initialize. Ready, the task transitions to the ready when the simulation time reaches the value ready time. In the ready state, the robot's motion is free in all degrees of freedom and is under the participant's full control, while in the ready state, no scoring is performed. Running, the task transitions to running when simulation time reaches the value running time. In the running state, the task officially starts, the scoring and the task timer enable. Finish, the task transitions are finished when the remaining time field of the task reaches 0 or when the task is considered complete. If all task time has been consumed but the task has not been fully solved, the field timed out of the task field will be set to true. The score will be updated in this state. Yeah. Right. So task information info message during every task. The state of the task is published as a ROS2 parabec message over a ROS2 topic. The message contains a series of name value pairs that summarizes the task state. See table 9 for the complete list of parameter names and descriptions. Please refer to the VRX API section of this document for further details. And so it's just, again, there's stuff we gotta learn when we actually do put it. So I think we had to put that for now, right?
Saying this 4 times with lightning round.
uh, so simulated pose reference to task evaluation. The task evaluation often involves the use of true stimulated pose of the objects within the environment. For the vehicle, the pose is evaluated at the origin of the model frame, which is coincidence with the base link reference frame. This origin is shown in the image below as the location of the tree of the red, blue, and green axis. True simulated position. Oh, okay. So all that means is just that all the readings that they're taking for positions will be at the center of that tree axis. So that is like basically a center point of your plot. Right? Similarly, for objects in the simulation environment, the true simulated location is the origin of the linked frame associated with the object. The image below illustrates this reference frame. So basically, all objects in the simulation environment also have some kind of origin. Right? Runs on environmental envelopes. In the competition, each team's solution will be evaluated over multiple runs per task, where each run will be use a different set of environmental conditions.
Oh, I agree.
Yeah, probably. The conditions will be distinct from run to run. These distinct configurations will be identical for each team, i.e. each team will see the same set of conditions as the other teams in the competition. The subsection below describes the elements of the simulation that may change over runs. So object location and orientation, fog, so that means you wouldn't be able to use cameras. Wind, waves, ambient lights. Shitty though, okay. And the summary of the environmental parameters. Oh no, we can actually like manually adjust these things. We should be able to. Right, so the VRX API provides a ROS2 interface for the teams for controlling all available actuators, reading sensors information, and sending receiving notifications. The use of ROS2 as the interface between the team software and the simulation environment does not require that the team software internally use ROS2. So it's well, so yeah, we're like you'll have Gazebo and ROS2, and then you'll have your own stuff running in parallel, and that would be interfaced with ROS2 to get the information using your ROS2 API. And so that is where all of these parts that they give us basically, that would be an actual like location within the API. Right? The intention of this competition is to be technology agnostic with regards to solution architecture and implementation. However, a single standard interface is required for the feasibility of the virtual competition. Every effort will be made to offer all teams support implementing the ROS2 interface to their software. For teams not familiar with ROS2, we highly recommend going through the ROS2 tutorials to get familiar with it, in particular ROS2 topics and services. Alright, table 11 to 14 summarizes the ROS2 APIs. Used for the computation, note that all topic names used for propulsion and sensors are configured via their respective YAML files. So again, there's just stuff we had to know for when we start the code. Alright, so the interface described above is generic to the entire computation, including all tasks. The task-specific elements of the interface described in the virtual robot X task description, which details the additional ROS2 topics and services used to support individual task execution. Finally, note that the VRX interface also includes elements that are not used in either of the generic or task-specific APIs. These are not needed for the computation and can be disregarded. Right, so submission and code execution. We expect to receive multiple files from each competitor prior to the event associated with each phase of the competition. These files will specify different aspects of the WAMV configuration as well as the team's controller. Please see the VRX wiki for an overview of how to participate in each phase as well as detailed instructions, blah blah blah. Basically, each task will be evaluated as follows. Each team's customized WAM fee will be generated. A Docker container running the VRX simulated image will be executed. This container will execute Gazebo with the VRX environment configured to run a particular task. Additionally, Gazebo will be configured to record a log of the execution. A ROS bag log file will capture all task messages containing the score. A team's Docker container and a team's image will be executed, so that is what we've given them with all our code. It's expected that the entry point of this Docker instance spawns all the necessary elements of the team's code. The competitor's code should interact with the simulation via the VRX API, determine the current task via the VRX API, and try to solve it. So it's one container we're giving them for all the tasks. Interesting. Okay. When the task has been completed or has timed out, the gazebo log file and the ROS bag will be saved and tagged appropriately. This process will be repeated for each run of each task and all teams participating in this event. This architecture allows the execution of the entire competition in batch mode. Teams may run a competition themselves locally using the same set of tools that will be used during the official events. These automated evaluation tools are available in the VRX Docker repository. We encourage all teams to use it for testing into solutions. So we have free review over how the apps program this.
So you can make sure that the task from.
Yeah.
So this the next step will be do task one.
Well, the next step is like everything up and running, and then we get the task.
So we can just I'll install credit on desktop. I'll see if I can bring it cannot be
Well, we could genuinely.
just make because you won't be having it
It's like
well just Google I'm on the home screen. Yeah.
What's gonna do is
shit. Nah, don't bring up.
there's
Tell
okay, because that the Mac Mini, and I think I forget what the other one called, but that one big one with a hand.
the
That's
Mac
basically
Pro or
like a
something.
towel. And
The cheese grater looking thing.
Yeah.
Is that
Yeah. Hold on.
It's an actual design by Apple.
Well, I can find me my shredded cheese in 60, I guess.
Is that tall? Is that tall? Well, officially everything's supported on Windows, so we could technically try and install it on Windows and see if it can run, and then figure out what we want to do from there. By delay, it would be nice to at least have one machine running it on. Well, we could run it on Mac.
yeah.
So we could try and get everybody to run it on Windows and just have one just to double check it on the officially supported environment.
So I come in Tuesday, so you try and like install what we gotta install and then try to make some progress on task one.
Mm-hmm.
Tuesday.
Genius. Say the word genius.
Sure, they have made that, but like pretty long this